next example comes out of section 4.3, trig ratio. The example goes like this. We have a point given to us, the point -2, 7. It lies on the terminal arm of an angle theta in standard position, and the question is what's the exact value for each of the trig ratios for theta. If I draw a picture of this, -2, +7, 1, 2, 3, 4, 5, 6, 7 is somewhere way over here. Clearly can't be on the unit circle since the unit circle only has a radius of 1, but it still can be on the terminal arm of an angle. It just means that it's outside of that circle. It doesn't matter too much whether it's on the unit circle or not. I still am going to look at the ratios within this triangle. So your SOHCAHTOA is going to help understanding sine, cos, and tan, and then we'll do the reciprocals after that. So this triangle, if I set it up, has one side here that's -2, and one side here that's +7. So if I were looking at tan of the angle here, I could say that tan is going to equal opposite over adjacent, so 7 over -2, or if you prefer -3.5, which means I also know cotangent, since cotangent is just the reciprocal of that, would be -2 over 7. Now if I want to do sine, cosine, and their reciprocals, I actually need a bit more information, and that is I need the length of this hypotenuse. Often I call it r for the radius. Sometimes you can call it h for hypotenuse if you're using SOHCAHTOA. But you will need to do -2 squared plus 7 squared equals r squared. So we have 4 plus 49 equals r squared. 53 equals r squared. So r equals the square root of 53. We don't need to worry about plus or minus the square root of 53 because r is always positive. And so if I'm looking at sine, it's going to be opposite over hypotenuse. 7 divided by the square root of 53. Cosecant is the reciprocal of that. So it's going to be square root of 53 divided by 7. Cosine is going to be -2 over the square root of 53, and finally secant will be negative the square root of 53 over 2. If the question said something about rationalizing, we would multiply some of these by root 53 over root 53 and get an even uglier looking answer of 7 root 53 over 53. It doesn't reduce, so I leave it just like that. This next one would give me -2 root 53 over 53. So I have 1, 2, 3, 4, 5, 6 trig ratios. If I notice this angle is in quadrant 2 or terminates in quadrant 2, which my answer should agree with the CAST rule. It's always a good thing to check that sine and its reciprocal are the only ones that are positive. Tan, cotangent, cos, and secant are all negative. So I'm happy with those answers.